Hi, welcome to my YouTube channel Electronics for Gate by Kota Venkanna. My mobile number 630-5826-909. Today I want to discuss the topic Ampere's circuital law or Ampere's work law. Ampere's circuital law or Ampere's work law. So here Ampere's work law and Ampere's circuital law is very important. In electrostatics, the complex problems can be solved by using a law that is called as Ampere's circuital law, or it is also known as Ampere's work law. So here the statement of Ampere's circuital law is that the line integral of magnetic field intensity H around a closed path is exactly equal to the direct current enclosed by that path. That is indicated as integration of H dot dl is equal to I. So here H is the electric field intensity. The statement of Ampere's circuital law states that, for example, if it is a circular path, so in the circular path 2 milliamp current is there. 2 milliamp current is there. So here already we know that the current when the current is in flowing, which can produce the magnetic field, in a circular path the current is flowing enclosed in the circular path. The current I, for example 2 milliamps is flowing, then the 2 milliamps which can produce the magnetic field intensity outside around the closed path must be equal to the current 2 milliamps. The current 2 milliamps. So here the intensity, if the intensity of current increases, then the magnitude of current or magnitude of magnetic field also increases. Then intensity of magnetic field increases. So here the intensity, the current produced magnetic field, that must be equal to around the surface the magnetic field intensity, that must be equal to the current enclosed in the circular path. That statement is known by Ampere's circuital law. And here magnetic field, ఇక్కడ magnetic field ని ఎవరు ప్రొడ్యూస్ చేస్తున్నారు? The current can produce. If the current is large, then which can produce large amount of magnetic field. So if the current is small, then the production of magnetic field is small. So that's why the intensity of magnetic field depends on the current. So that's why the magnetic field intensity around a closed path must be equal to the current enclosed by that path. That statement is known as Ampere's circuital law. So now we see the proof of magnetic field, Ampere's circuital law. we will see the proof of Ampere's circuital law. So here it is a current carrying conductor. Let this is current carrying conductor, and the direct current which can carry the direct current, and here this direct current carrying conductor is enclosed by circular path. Let us consider it is a conductor which can carry the current I. Okay, so which is in the direction Z, and this conductor is in the Z direction. Okay, next let us consider a circular path enclosed the conductor. It is a circular path. Let us consider this is a circular path which encloses the conductor, which carries the current I. So here let us take a point P on the y-axis. So the distance from center 0 to P is small r. So the enclosed path is in the direction of A pi. Let us consider the enclosed path is in the direction of A pi. A suffix pi. So here the current I, and this is the distance from center point to P or small r, and this is the direction A pi, and this is the point P, and this is the Z direction, this is the X direction. Okay, so for the proof of Ampere's circuital law, so here dl, consider dl is at a point P is a small distance. Let us consider dl is a small distance at point P, and which is in the direction, this is the dl. So which is in the direction of A pi, which is also in the direction of A pi, and which is tangential to the circular path, at a point P. So therefore dl is written as r d pi A pi. So this is the small r, the distance from center to point P, and this is the d pi, the differentiation of pi, and A pi is the direction of enclosing circular path, that is A pi. So that's why the small distance at point P dl is written as r into d pi into A pi. Equation 1. Let us consider equation 1. And from the Biot-Savart's law, the electric field intensity at point P. From the Biot-Savart law, the magnetic field intensity at point P is written as H is equal to 1 by 2 pi r A pi. 1 by 2 pi r A pi. So next equation 2. This is equation 2. So from the Ampere's circuital law, What we know that integration of h dot dl is equal to I. H dot dl is equal to I. So first we have to do h dot dl. H into dl. So that's why h dot dl is equal to h into dl. So 1 by h, in the place of h we have to substitute 1 by 2 pi r into a pi into dl, r into d pi into a pi. Okay. So this is I by 2 pi r. This is I by 2 pi r. I by 2 pi r. So here h is equal here h is equal I by 2 pi r. I by 2 pi r into a pi, and h dot dl is equal I by 2 pi r into a pi into r into d pi into a pi. So r both are cancelled. So a pi into a pi. What is here? A pi into a pi is equal to 1. So that's why h dot dl is equal to I by 2 pi into d pi. So now then we have to integrate both sides. So that's why we want here h dot integration of h dot dl, which must be equal to I. First we have to do integration h dot dl, then it will becomes I. So that's why here h dot dl is there. Then we have to do the integration both sides. Then integration of h dot dl is equal to integration of I by 2 pi into d pi. So integration, this is the enclosed part, is a circular path which starts from 0 to 2 pi. So the integration pi is equal, we have to take integration pi is equal to 0 to 2 pi. So here integration of h dot dl is equal to integration pi is equal to 0 to 2 pi. Why? Because here the enclosed circular path is in circular shape which starts from 0 to 2 pi, and 0 to 300 or 360 degrees. 0 to 360 degrees, that must be indicated with pi is equal to 0 to 2 pi. So that's why we have to take the integration pi is equal to 0 to 2 pi. So here integration h dot dl is equal to I by 2 pi is a constant value. So that's why I by 2 pi and integration pi is equal to 0 to 2 pi d pi. So integration of d pi is equal to pi. So that's why I by 2 pi integration of d pi is equal to pi, lower limit 0, upper limit pi, 2 pi. So that's why we have to apply the upper limit. So this can be written as I by 2 pi. So upper limit 2 pi minus lower limit 0. So that's why it is equal to I by 2 pi into 2 pi. So 2 pi cancel, the remaining value is I. So that's why integration of h dot dl is equal to I. So this is the statement of Ampere's circuital law proof, which is proved. The integration of h dot dl is equal to I. So that is the line integral of magnetic field intensity around a closed path. This equation integration of h dot dl indicates the line integral of magnetic field intensity around a closed path that must be equal to I, the current enclosed by that path, and it is also known as the magnetomotive force around a closed path must be equal to the current enclosed by that path. So this is the proof of Ampere's circuital law. In next class, we will discuss the applications of Ampere's circuital law. In next class, we will discuss the applications of Ampere's circuital law. So, thank you. For daily classes and for any updates, subscribe my channel Electronics for Gate by Kota, Venkanna. So in this channel, I want to discuss more subjects about engineering subjects. So that's why subscribe my channel. Thank you.